Dear friends, bonjour à tous. So welcome to this panel. I'm Zhen Dongsan, the Chief Executive of CGN UK. I worked long time in the CGN world. This is almost the 35th year working in the CGN. Today we're going to talk about the digitalization, how digitalization will contribute to the excellence of nuclear industry, of course, nuclear power. We are living in the digitalized society. Well, our industry, almost all the industries, benefited a lot from these advanced technologies. And nobody, maybe very few, but nobody now can live without the, let's say, internet or the informations. I see everyone, you may even sitting here reading your cell phones. That means you are linked, connected to the grid, and you may collect it each other. So how nuclear power, we as an industry, we can benefit from this advanced technology, and how nuclear power can benefit from this digitalization. I'm very pleased and delighted to chair this panel, but also I'm honored to invite our 4 specialists and the guests. From your right hand, Ms. Shi. She is the Deputy Chief Engineer of China Tech Energy. China Tech Energy is a company, is a subsidiary of CGN. Well, you may know that China Tech Energy has already developed so-called safety classified digital control systems. The name is Firmsys. So Ms. Shi, she as a director of that project from the beginning of the innovation and until now for the full application in some of the Chinese nuclear power projects, as well as some overseas projects. And then Stephen Lacey, Customer Business Director of Nuclear Instrumentation and Control from Rolls-Royce. Okay. Maybe I'm not in the good order, but I'm sorry. And then Mr. Thomas Gruang, Vice President of Energy, Process, and the Utilities Industry from Dassault Systèmes. And finally, Mr. Philippe Destombe, Chief Information and Digital Officer from Framatome. So I will invite our guests to have a short presentation, and then we will open the floor to have some questions to our guests. Okay, I may now invite Mrs. Shi to have a short presentation.
Dear colleagues, good afternoon. I'd like to share brief information about the digital IC in China and ongoing R&D project, or what we are doing now to further take advantage of digitalization. Okay. As we all know that for the past decade, China is the biggest market for new-built nuclear power plants. More than 30 units have been put into operation, and some are still under construction or planned to be built. The reactor types covers most of the Generation 3 and Generation 4 reactors. In China, we don't develop, and we also can't develop all the technologies we need. We want to establish an open and mutual benefit relationships with our partners. In fact, we have long-term cooperation with partners from France, Russia, Germany, Spain, Japan, South Korea, etc. For the DCS system in China, since Taiwan Phase 1 and Lin'ao Phase 2 projects, all new built projects, the solution of I&C are based on digital control systems. And some operation nuclear power plants, including Qinshan, Diabei NPP, are performing their DCS modernization, also based on digital control systems. It is not exaggerated to say that almost all the systems, all the platforms we can find worldwide have been used in Chinese market. And our CGN also published her own developed safety and non-safety classified DCS platform, which also have been applied both in domestic and international projects. So there are many experiences and feedbacks from all the above to help us to understand the DCS system in nuclear industry. Here, I give you some example. So this is the main control room of the CPR-1000 reactor. And there are 14 CPR-1000 units in operation in China now. The DCS is based on Mitsubishi's and CGN's DCS product. And this is the main control room for ACPR-1000. There are 4 units are under construction, and the first unit of Yangjiang 5 was connected to grid in this May. The safety DCS and the non-safety DCS are both supplied by CGN. And this is the MCR for China-developed Generation 3 reactor, HPR 1000. So this DCS is supplied by CGN or by Pharmatone. As you can see, in this MCR, more digital video are applied. Then the traditional BOP has a new name, ACP, Advanced Control Panel. By employing a secondary DCS on this ACP, the panel size is reduced, fewer equipments installed on it, so it is easy for maintenance, while more operation available to the operator. And if we add a connection on this ACP with a digital plant model, the operator can verify important operations before he really push that button. Also, the ACP can propose intelligent operation suggestions in a real-time manner. So the above is about the current status of DCS in China. And now I'd like to share an ongoing R&D project in our company. The purpose is to further take advantage of the digitalization, and we are going to build an intelligent operation and maintenance system of DCS. And we started from the maintenance part. So digital control systems have so much diagnostic data covering different equipment levels to support maintenance activities. For example, in Yangjiang 5 reactor protection system, there are more than 33,000 diagonal signals updating quickly in every 15 to 200 milliseconds. They are not only stored and processed in DCS itself, but also ready to be sent out. So this is one of the databases of this intelligent system. So we will also include other two types of big data. One is the inherent characteristics and the life cycle data of the product. For example, the data sheet of every electronic component and chip on the DCS board. And another is the operation and maintenance data about DCS. For example, the data about spare parts. In the process of finally getting valuable data set, factors of data quality, data security, and data standard should be considered very carefully. So what we can do with this system, we consider this design 4 category functions on this system. The first one is DCS equipment reliability management. The second, the intelligent DCS tool inspection support. And the third one is predictive maintenance support. And the last one is DCS spare parts management. And now there is a first step prototype in Shanghai, one office of CTEC. You are welcome there to visit this first step prototype. So that's all for my brief share. Thank you.
Thank you, Ms. Shi. Actually, China Tech Energy was established in the year 2005, and it's a very young company, but through more than 10 years hard work, so they now have the own products, both in the software and hardware, in the digital control system and the protection systems. So I think Ms. Shi just gave you a brief introduction. Coming next, let's welcome Stefan from Rolls-Royce. You know, Rolls-Royce, it's a great partner of CGN, and they played a lot of important role in the Chinese nuclear program, as well as worldwide. Stefan, he joined Rolls-Royce in the year 2012, and he is in charge of the nuclear instrumentation and control sales activities worldwide, with the responsibility of developing new and profitable opportunities, managing the internal bid process and the contractual negotiations, and maintaining customer satisfaction. Before joining Rolls-Royce, he was employed 14 years by Air Liquide Group. So I think Stephanie has a very rich experience and also a very wide view on this digitalization. Please, Stefan.
Good afternoon, everyone. Thank you so much, Mr. Zhang Dongshang, for these nice words of introduction. Thank you very much to CGN for organizing this panel. And thanks to all of you for being here so late after 3 hard days of exhibition. You probably, like me, found that everybody during this exhibition had maybe some different thinking about what digitalization means. It has different meanings. It is a wide subject. And certainly what we will find out is that on such a wide new subject, potentially, collaboration is going to be needed among several companies. It's not like one company can make it all, right? And this is all the more important for me to be very proud to be a supplier and potentially tomorrow also a very large partner of the CGN group. So let me tell you, coming from an instrumentation and control perspective, but also in the nuclear industry, but also as part of the wider Rolls-Royce group, how we feel digitalization can be a game changer in our industry. So I'm not going to obviously make a very large corporate presentation of Rolls-Royce today, but what I want to insist on are really two very fundamental aspects of the Rolls-Royce group, which as an employee I've always been impressed with. The first one is about technology, and that's probably where you know very well the Rolls-Royce group in its different market segments. Not only nuclear, obviously, but also aerospace engine, and also other market segments like for power systems or for defense engines. So technology is very deep in our DNA. But it's not only about technology, it's about the services that we render to our customer, leveraging what we call data science. And that's where we start touching the digitalization aspects. And this data science is another big part of our DNA at Rolls-Royce, and especially in the aerospace sector. And I'd like to make some similarities here between where we have come from in the aerospace sector and where we could go in the nuclear sector. Because if you ever had a chance to visit our operations for aerospace in the UK, we have, I would say, a very significant control room over there, an operations center, in which you can see live on large screens like this one, all of the critical data of all of our engines worldwide in operation. And that enables our data scientists to make analysis and to provide some very clear instructions to our maintenance people on ground to facilitate and optimize the maintenance of our own engines. And that supports our business model of pay by the hour of the engines that we deliver to our aerospace customers. So this is also a strong DNA on top of the technology. So in the nuclear sector now, where are we? Well, just like our colleagues of CTEC, we are an important supplier of digital INC technologies in the nuclear market for more than 30 years, starting obviously with the French fleet, on which we have installed our digital safety INC platform Spinline since the beginning, and expanding to the worldwide market, including in China, on which we are present on more than 40 reactors these days, and in other parts of the world, such as Finland and other very stringent regulatory regimes. So that's our pedigree as an original equipment manufacturer in the nuclear industry. But now comes also the data science part and how to leverage the value of data for our customers. And yesterday, one of my good colleagues out of the US made a speech about that particular aspect and how we develop value for our customers in the US. And what our colleagues have developed is a process of using the data that they can collect not only from our own equipment, but from everywhere in the plant, analyze the data, and provide to the customer a value which we actually estimated very precisely to be close to $15 million of savings at 5 different facilities. And the reason of why we could generate this value for our customer is by avoiding them to do some unnecessary works. And that really echoes back to what we do in the aerospace sector by really analyzing and fine-tuning data that we collect in order to provide some optimized maintenance and operational features to our customer. And these values are not just there as a number in the sky. They are, validated by these customers, which we would be happy to invite you to discuss with. So we have these two parts in our nuclear sector as well that are extremely important to us, the technology part and the data science part, and the data utilization part with some real outcomes so far already with real utilities and with proven numbers. So, having said that, and as an engineer and as an OEM of digital INC worldwide, my dream would be that, for our company and for our industry, we could actually combine both aspects. And this is the symbol of the iceberg, basically. So it's a bit like if we were at the tip of the iceberg, focusing obviously on our platform, digital INC platform, for safety purposes. Let's don't forget that this is first there to ensure the safety of the plant. That's what we are here for. However, there is a rest of the iceberg. If you think about it, our digital platforms, like Mr. Shi said recently from the CTEC perspective, is capturing data from thousands of sensors, actuators in the plant that can be used in order to provide some more predictive maintenance to the operators. So we could use our platforms at both these levels to generate more value and to make all the new nuclear power plants built with digital INC technologies. So that's really what we are looking forward to doing with some proven evidences already, both on the technology side and on the services side. And that's, I think, we feel what digitalization is about in our field and how we can bring value to utilities by ensuring safety at the same time. So thank you very much for your attention. I hope it will open up some discussions later on during the rest of the panel. Thank you again, Mr. Zhang.
Thank you, Stephanie. The day before yesterday, CTEC signed agreements with Rolls-Royce on the joint, working on some of the projects, not only for the ongoing projects, but also for the future projects. I hope that cooperation will help not only in the UK's project, but also in the Chinese nuclear project, as well as for serving the other countries. The market is huge. It is through a kind of cooperation that Chinese companies can really be involved, also entered in the world market. Thank you, Stephanie. So coming next, let's welcome Thomas. Well, Thomas is Vice President, Energy Process and the Utility Industry, Dassault System, since 2016. Before this function, he worked in Sasol Bay, and he worked in some of the consultancy companies, and also in Arriva. So he has rich experiences in not only in the Dassault, but also in the good background in the nuclear power projects and plants. Welcome, Thomas.
Thank you. Thank you for being here. Thank you for hosting us. So today, we'll discuss one more facet of what digital can mean to the nuclear industry. And we'll visit what this facet is through the eyes of Dassault Systems. So a quick word about Dassault Systems for those of you who may not be familiar with our company. We are a scientific and technical software company operating since little more than 35 years. And we have invested in the nuclear industry since several decades, and now accelerating globally, as you may have heard yesterday. So transversal continuity is the theme of this presentation, which hopefully I will be able to start, yeah? So somehow we want to state that beyond digitization, there is something to do. Digitization, seen from us, is really the matter of optimizing each stage of the life cycle of a nuclear plant, each organization capability. And somehow, digitization is here to deliver local optimization. But there are ways to go beyond that, because digitization offers savings, reduces the number of errors, but it's possible to go beyond. And to go beyond this vertical focus of optimization for each stage of the life cycle, if someone can click on my behalf, because, yeah, thanks, is what we call transformation, digital transformation. And transformation really means enabling a horizontal approach to digital by connecting the tools that are used at different stages of the life cycle, connecting the organizations that use these tools, and also connecting, of course, the data. This is the reason why Dassault Systems, about 10 years ago, decided to stop developing standalone software products, but to group everything in one single platform to be able to deliver this horizontal transformation. Because our customer started to tell us that software products were extremely good for the different specialists who are using them, but we are not helping them to collaborate, because software are over-specializing specialists, and data is no longer flowing between organizations. So this is really this view that I wanted to highlight today. So if we go to the next slide, I would like today to briefly highlight some examples of transversal digitization that enable business transformation. So from end to end, so the different examples I wanted to share today are requirement management, configuration management, supply chain management, and finally, field activity management. So if we go to the first one, which is requirement management, most of you know what requirement management is about, especially in the nuclear industry, which is a highly complex, highly regulated industry, where there's a very large number of requirements, as is the case in other mission-critical and highly complex industries like aerospace and defense, which is the DNA of Dassault Systems. However, in this industry, for a long time, the management of these complex requirements has been done by hand, leveraging documents or even electronic documents. And this is a resource-intensive process. And this is a process that is prone to errors. And this is why we believe very much in the fact of deploying a very granular requirement management throughout the entire life cycle of the assets that can systematize the proof of compliance towards the safety authorities and basically automate part of this proof of compliance. So requirement management is really one of the main use cases that we have deployed with a number of companies throughout the world in the nuclear industry. For example, with the largest nuclear plant operator in Japan, most recently. So beyond requirement management, which is the starting point of system engineering, we can also discuss about configuration management, which, as you know, in the nuclear industry, means maintaining a continuous equilibrium between the requirement that we just discussed, between the configuration of the physical nuclear power plant, and between the information that describes all of this. So maintaining this equilibrium is something that has been described long ago. The theory of it has been around for a while. But today, our purpose is really to ensure that this can be done in an efficient way. This can be automated because there are three different areas from which this equilibrium can be broken. Requirements may change. Information may change. And the plant design itself may change. So today, there are efficient ways to capture any changes that will occur on the facility configuration documentation by automating detection of which document will be changed. There are efficient ways that I described just before to detect when requirement will change. Here again, when documents are broken down in a very granular way, we can automate the detection of changes in requirement. And also the plant configuration, which traditionally is checked with inspection, can also be automated by ways like non-destructive testing or drone inspection or such digitized way to capture information. And basically, weaving a continuous thread across these three areas allows to automate part of the configuration management, and again here, deliver a proof to the safety authorities that all the information, and there's a lot, hosted by operators is up to date and well maintained. The next example I wanted to comment, if you can click one more time, is the supply chain management, which is a complex topic in the nuclear industry, because nuclear power plants are large, complex items, and also, very often, when one nuclear power plant is built in an export project, it is necessary to diversify the supply chain to localize most of it. And localizing the supply chain in export project can be extremely time-consuming unless there is a continuity that is open between the engineering, procurement, construction company and the local supply chain, which is something that we have done several years ago in Russia with Atomstroy-Export, part of the Rosatom group, whereby the supply chain management is done collaboratively between the EPC company and all of its suppliers. You have the example of this portal, which is called IonCom, accessible on the internet, powered by Dassault System Solution, where more than 600 suppliers of Atomstroy-Export are self-declaring, self-updating all the information related to the equipment that will be fabricated, procured, used in the field for construction, and also during after operation. So that's one more way to deliver continuity from the end of the design stage and start of construction down to operation. Last example I wanted to share related to digital continuity is about field activity management, whether, again, this is fabrication, construction, commissioning, operation, inspection, etc. Lots of these processes continue to be very manual, even if they rely on digital tools. They are document-centric, and really the purpose that we promote to the nuclear industry is to go data-centric, which means managing data at a much finer granularity than the document itself, so that collaboration can be improved, and so that document-intensive processes linking engineers in their offices to field personnel on the ground can be done seamlessly. So in short, if we go to the final slide, the traditional view of passing information between owner-operator to EPC company, then back to owner-operator, and then when there's a big modernization project, back to EPC, and so on and so forth, can change and reach, if you can click one last time, a different view, which is a continuous handover between organization, between disciplines, from the very early stages of a nuclear power plant project down the road to the decommissioning. It's really ensuring a continuous work between EPC companies, between operators, the supply chain in the context of the requirements that will allow full traceability, including to testing, inspection, and certification companies, as we do, as you may have heard this morning if you participated to this workshop with Bureau Veritas Nuclear. So this is the highlight I wanted to make related to digital transversality. Thank you, and thanks again, Mr. Dongsan.
Thank you, Thomas. Thank you, Thomas. You know, Dassault has already established R&D center in Beijing, in Shanghai, and yesterday the chairman of Dassault told me that that's why he's looking for establishing another R&D center. I say, why not in Shenzhen? Because I'm in Shenzhen, and CGN is in Shenzhen. Well, what Thomas presented to you just will make me, you know, something that was 25 years ago. You know, when I was a nuclear safety engineer in Daya Bay, you know, I carry out some set patrols. You know, we have a small handbook and the pen, and then we just note the parameters and then come back to the main control room and to see anything. Well, now the field operators, what they use, they don't need any more handbooks, right? They will have direct transmittal of the information from sites to the main control rooms. It remains also, well, remind me that, you know, now in the Hinkley project, Hinkley Point project in UK, our partner EDF, jointly with CGN, we are working on it. Now, not only the configuration management, but we are commanding the project by 4D model. Normally it's a 3D, but we added the timing because time is essential, right? Of course, I think a lot of design institutes, you are applying or using 3D models, right? And I saw my friend from Framerton, he's sitting there. 20 years ago, you know, the drawings, we just used air freight to send from Paris to Daya Bay, and then we make the drawings on site. Now we just need a printer on site. It is the digitalization which facilitated not only our routine works, but our communications, and also the site fulfilling site needs. Since I talked about my friend Framerton, so coming next, let's welcome Philip from Framerton. Philip, before he joined Framerton in the year 2016, he worked in the EDF group, in the nuclear fuel department, and also in the, just after EDF merged British Energy, he worked also in the EDF Energy in UK to establish in the information systems. Yesterday, I still remember Bernard Fontenay, the CEO of Framerton, he explained since 31st December, 2 a.m. or 2 p.m., I don't remember, but Arriva comes back. Before you know, Framerton comes back. Before you know, some of you may know Framerton, and then there was Arriva, now Framerton comes back. So let's welcome Philip.
Okay, so good afternoon, everyone. Thank you very much, Mr. Sangonchang. And I think the title of my presentation is Framatome Digital Transformation. So the key word for me is transformation. Digital is now everywhere, so it's now how we're going to put in place digital and to digitalize process activities, and that will mean, obviously, we need a big transformation. So Framatome at a glance. So as just said, Framatome is, let's say, a new company. Nevertheless, for 60 years, Framatome teams has been involved in the nuclear sector. 4 main activities in Framatome: designing nuclear plants, especially in the NSSS sector, designing and manufacturing component and fuel assemblies, INC systems, and services on reactors all around the world. So we've been involved in the construction of 92 nuclear power plants, currently, we've got there are 14,000 employees within Framatome. We're serving over 250 reactors all over the world, and we've got a turnover of 3.3 billion in 2017. So after these few words on Framatome, so what's clearly, so how we're going to put in place all what you've heard this afternoon, how we're going to put that in place within Framatome. So I think clearly the objective is of the digital transformation program is to deliver change, and change not only on the internal processes, but also on the external processes. So clearly the objective is to get a more efficient company by reviewing, redefining both internal and external processes. I'm going to detail a little bit more what has been included in our roadmap. So on the right side, you've got something that Bernard told us a few months ago, but you can read it. But in fact, digital transformation will be the merging between, in fact, new ideas coming from businesses, how we're going to improve our efficiency, and merging this with new technologies to take the best of the new technologies to better serve our customer, to work in a more efficient way with our suppliers. That clearly for me, and I think for Framatome now, in fact, the objective of the digital transformation program. And that will include all you've already heard this afternoon, to be data-centric, to review the processes, to work on an digitalized end-to-end processes. So how now we've organized, and how now can we deliver and go in this, follow this path? So on the left side, you've got the 5 strategic axes of Framatome. So proven and sustainable expertise, performance in delivering, agile and adaptive organization, safe and competitive solution, and to have an internal development. How we're going to support these 5 strategic axes is clear, because in addition of these 5 strategic axes, 5 key programs have been put in place within Framatome. All these programs will deliver change. So the first one is knowledge management. So that's clearly the way just to capitalize all the knowledge of Framatome. Then we've got operational excellence and commercial excellence. And I'm just going to be a little bit longer on the 2 last ones. So system engineering is a key one, especially in the digital transformation one. We're going to implement into system engineering. We are going to review the processes within engineering. And for example, the PLM tool supported for what we're going to use, in fact, the DASO tool, will be the tool we're going to use to implement the change by putting in place a system engineering methodology within Framatome. So that's just an example of the digital transformation roadmap. So I'm going to give you now an idea of what else is in the transformation, digital transformation roadmap, and how we put this in place. Okay. So to be able to transform, in fact, the company and to digitalize the company, we try to organize this in 3 different layers. So the first one is the layer, what I call enablement. It's not, well, that's going to be very quick for this one. It's just we need to be technically ready and up to date of new technologies. That's the key thing. Without this, you will not be able to deliver, for example, application for workers on the field to work more efficiently. That's just an example. But to do this, you need the infrastructure to be able to do that. So the second layer is digital business optimization, so keyword optimization. That's very important But the idea is we are not going to redefine the businesses of the company. We're just going to look at the key processes, and if we introduce digitalization in these processes, we'll be able to improve it. So it's just digitalization of existing processes. So that's obviously can deliver a lot of savings. But clearly the goal and what we want to achieve is clearly a transformation. It's not just digitalization of the existing processes. It's to redefine and to change the ways of working, both within the company and with our supplier and our customer. So on the right side, you've got the few examples and a few items we have already launched in 2018 and 2019, and what we want to do in 2020, because there are so many ideas coming from the businesses. Now we just need to prioritize to be sure that on the technical side we're mature enough, and that on the business side we're ready to do the change. So, organization now of our program. So following this, we've defined 5 ambitions. So the first one is enhance collaborative ways of working with third parties. So that's obviously both supplier and customer. We will have to exchange in the future data, no more documents, but data with all our, let's say, shareholders. The second one is optimize and transform internal processes with an extension sometime with external processes. You can see many things in this column with a few things and few ideas that are in red boxes. So that red boxes are the first priorities and the projects we have already launched. So in this one we've got paperless and digital processes for operation and for support function. So that's paperless, for example. We're just taking existing processes, digitalizing them, just to move from a paper, let's say a process based on paper, to a paperless process. We're not going to change the process, it's just digitalization. Then we've got virtual augmented and mixed reality for training, design, operation and sales. I think you've probably had the opportunity to go on the Framatome stand to see what has already been done, for example, with HoloLens for the IB install-based activity. So that's very promising for our future services. The third one is system engineering and product life management. So that's a key and one of the biggest projects we have already launched, is to, let's say, deploy system engineering supported by a PLM tool. The next one is manufacturing and execution system. It's a step forward, let's say, Industry 4.0. The idea is to get it to go to let's say, paperless activity in the factories, and to do the link between our supply chain tools and the work that is done on the field. That was for the second ambition. The third ambition is create value from data collecting and analyzed. So you have already heard that data is going to be key in a digital world. So that's always the case for us. And the first thing we're going to do is asset tracking IoT. So it's to use RFID chips on our material to be able to locate them very quickly in the plant, for example. That's now a project going live. The fourth one is enhance workplace and internal collaboration. And the fifth one is reinforce current business and develop new business. For example, so we've got digital commercial offers. So it's to have a catalog of services available on tablets, available online, and in the future to be able to go to see and to visit our customers, and to be able to see and to show them, for example, with the 3D glasses, what we're selling him. Instead, and before doing it. So this is the organization of our digital transformation program. You've got in red boxes our key priorities. Now, just and to finish, a few examples. So again, on these 5 ambitions. So just under the 5 ambitions, you see what's targeted under these 5 ambitions. So in a nutshell, I think the benefit will be to increase traceability, to increase efficiency, to increase knowledge, and to decrease injuries, to decrease lead time, and to decrease costs. That are the key drivers we've got within the transformation program. So now if I'm back on a few examples, so you can see, so first column, we've got NCD Digital, so that's work we're currently doing with Bureau Veritas, for example, within the plants to digitalize the processes. We've got nuclear acid connectivity, so that's clearly things we've started to do with EDF to optimize the work of our mobile workforce on the plant. Then we've got second column, I already told you about PLM and MES. One thing on the bottom line, we've got paperless for service and operations on site. So we've also promoted a few standards, for example, to be able to develop mobile application, to avoid, let's say, too many tools within the company, to be able to have some standards to develop, for example, mobile tools. Then we've got create value from data. So an example, for example, data acquisition and analytics for predictive maintenance. A few experience. We've got one in the US, for example, for a customer, working with him just to try to help him on predictive maintenance. And we're going to put in place hackathon before the end of the year around data, for example, because we've got many ideas on this item. Fourth one is enhanced workplace and internal collaboration. So we have set up, let's say, internal resources to be able to create our own MOOC and training online. That clearly generates a great success within the company, and that's quite easy to do. And on the last column, for example, an exercise digitalized cockpit is also another initiative from the install-based activity, just to be able to manage spare parts, for example. Okay, so that's just a few examples. That's where we are. That's a key process for us. We're clearly expecting a lot of deliveries to be able to better serve our customers in the future. Thank you very much.
Thank you, Philip. You know, Framatome works with Chinese nuclear, let's say, developers or utilities for, let's say, this year is almost the 40th year. Why? Because I remember the 4th December 78, Deng Xiaoping announced when he met the French foreign minister, he announced that China will import from France 2 reactors. So that then the project started in the 87 in Diabei. So since then, we have a very close cooperation with Framatome. So I think, well, Philip didn't talk about one of 4 business in Framatome, which is digital control systems supplier. Well, he talked about the transformation, digital transformation within Framatome for the more management on the processes. Thank you very much. So those 4 respected guests give us presentations, and I observed there are a common point. They are all serving to the customers, right? And I am one of the customer. I just want to say several, maybe very simple, let's say, by the transformation of the digitalization and the nuclear power plant, what we can get. You see, at least higher reliability in the instrumentation and the control and the protection, better man-machine interfaces, and better transmission of informations, data, and of course, a lot of other things. I talked about the obsolescence that the old nuclear plants we faced, because few manufacturers, they still produce the relays, well, still in some of the old plants there were widely using those relays. So now we still have several minutes. The stage is open. Welcome the questions. And I will see, is there any question asked to our panelists? I didn't see. Mr. Grant, are nuclear safety authorities open to such drastic transformation? That is to say, from the relay to the digital controls, instrumentation, and the control systems.
Thank you. So that's actually a very good one. Thank you for asking, whoever this is. Yeah, there is an understanding that nuclear safety authorities are extremely conservative, that they do not want to hear anything about digital. And actually, from the experience we gained in a number of different countries, our experience is today that it's rather the opposite. Because whatever can deliver more efficiency in the control and conformity check process, whatever can deliver a more reliable access to the source of the information is something that is viewed extremely positively by safety authorities. And as a matter of fact, as was highlighted by Philippe Detombe, and as I briefly mentioned, testing, inspection, and certification companies, some of the most forward-looking, such as Bureau Veritas, who work on behalf of safety authorities, are now moving fast in this direction, and this is something that is well accepted. So the answer is yes.
Any other questions, please? Mr. Shi, as shown in your presentation, Yangjiang Unit 5 is the first set of application of firmsys for 1,000 megawatt unit. What's the user's feedback about firmsys?
Thank you. I'm the right person to answer this question because I'm the technical chief engineer of Yangjiang 5 unit project. Sure, firmsys is the first set of indigenous safety classified platform in China, and the Yangjiang Unit 5 is the first set of application of firmsys for 1,000 megawatts units. So this is not only a challenge for CGN, but for all our sub-parties, including CTEC, the PICE, and the end users. And CGN group set up very powerful and leading and decision-making committee for this project. All parties working cooperate closely under this lead. And for the CTEC part, the project program was set up and scheduled with the consideration of all possible risks. For example, we set up 3 prototypes to verify the different aspects of the design. And we also adopt an open attitude and listen to the user carefully. The end user is invited to participate deeply each stage of this project. So the user knows this firmsys platform very well. In this May, Yangjiang 5 unit was connected to the grid successfully, and the users' feedback is positive. They pointed out firms fully realized the function they required, and the equipment is reliable and user-friendly. They also appreciate that the quickly response from CTEC. I think in this project, we do stick to the CGN's core value, doing things right in one go. Thank you.
Thank you, Ms. Shi. So next question is to Stephanie. What are the main trends in the development of nuclear INC technology in the near future?
Well, certainly, digital INC will still have to be licensable and safe. That remains, the baseline. At the same time, there is going to be more and more pressure on costs. Okay, and that can be achieved both through the hardware part and through the engineering part. Related to hardware, it's going to be about compactness. Rolls-Royce is in the aerospace business, is also in the submarine business, and in a submarine, you make a reactor protection system with 4 cabinets only. Okay, there are less functions than on a commercial nuclear power plant, but it gives you the challenge. Why not trying to make it in 4 cabinets for commercial application as well? And however, most of our costs is not on hardware, it's on engineering. It's about 60% of the cost of a new INC project. And on engineering, modular designs is going to help to reduce costs. On top of that, we'll have to be very careful about cybersecurity in the future. We did not talk much about cybersecurity today, but both through the processes of development and through the technology features themselves, the new digital safety INC platforms will have to be cyber secure to convince the end user and the safety authorities. And finally, on the basis of all of this data that we mentioned earlier, INC can help be more predictive in terms of maintenance, because we need not only to think about initial costs of acquisition, but the total cost of ownership that the INC systems is going to bring to the industry, taking care of predictive maintenance, and as you said, Mr. Zhang Dangshang, also the obsolescence management. Proactive obsolescence management is going to be a key, because our INC systems are there for the next 30 to 40 years once installed on your plants, right?
Thank you, Stephanie. Well, I think this will be the last question to Philip. C'est vraiment égalité parce que, each guest has one question. So the question to Philip is, what organization have you put in place to be able to deliver this roadmap you presented? Philip.
Okay, so this is the last question. I'm going to be very quick. So the organization is quite simple. It's a really small central team at a corporate level to be able to manage the roadmap, to manage a digital factory able to deliver all this small application. And this small centralized team clearly works with digital ambassadors that have been nominated in all the business units. And it's clearly a network. So innovation and digital is not the property of a few persons in the company. It's clear everyone has been mobilized, everyone is invited to work on these workshops, to be able to, for us, in fact, to capture the best ideas.
Thank you, all the respected guests. Thank you all join us. I think the time is short, is limited. Certainly you have questions, and I think we're open. If you have, you wish to have further communications or inquiries, just let us know. And my colleagues, or you are more than welcome to CGN stand, not far from here. Thank you very much.